1, so I'm going to immediately get rid of that pi. That way I'm not dealing with it along the way. I'm not trying to plug it in my calculator or anything. All right, to get rid of that 4/3, I'm going to multiply by 3/4. Right, Arena? We're going to multiply both sides by 3/4. And we're going to come up with R equals 729. So if 729 equals R cubed, I take the cube root of both sides. I pause this for a second while I am reconnecting. It is sending a request. It is just... Okay, so where were we? I could rewrite some things. So this was 3/4. This was multiplied by 3/4, which got us to 729 equals R cubed. I took the cube root of both sides, and I should come up with R equals 9 centimeters. Cuckoo, ka-choo. Any questions on that? No? Oh, you started saying something. I thought you were starting to say something. You were saying something? And then you stopped?
She didn't say anything.
Did she say anything?
I don't think so.
Okay, what questions do we have from the homework? Chris? 12. Correct me if I picked the wrong one, because no, I should get the right one here. So 12 is a good question, a good question. Not good in the fact that it's one of my favorites. Good because it's got a nice little twist to it. Okay, on 12, we have a cylinder inscribed in a sphere. And I want to get that area in between. So if I had no idea what else to do, I would say, hey, Mr. Papian, I know I have to get the volume of the sphere. I have to subtract the cylinder. I'm not sure how to do it. But that's a good start. All right, so I need the volume of the sphere. I need the volume of the cylinder. I need to subtract the cylinder out of the sphere. Well, the sphere volume isn't bad because I know the radius. The radius is 10. So we're just going to do 4/3 times pi times 10 cubed, which comes out to 4,000/3 pi. Now I need the cylinder in order to subtract that volume out from inside of it. To get the volume of a sphere, not of a sphere, of a cylinder, I need to have pi r squared times the height. The height wasn't a problem because it's 16 centimeters. It was the radius that was the problem. And I'm going to redraw this really quick. So I'm going to say I have a sphere right here. I have a big sphere and I got this cylinder that's cut out right through it. I also know the height of the cylinder is 16. So the height of my cylinder is 16 units, centimeters, whatever we have. The only other thing I know is the radius of the sphere. Well, if I start in the center here, anytime I know a radius, I'm always going to take that radius and go to the corner of my object. And the radius, I believe, was 10? Yeah, it was 10. My radius is 10 of my sphere. Well, that from here to the corner of this object is 10 as well. Well, if I go straight across here, I create a right triangle. I also know that this side is 8, because this is the halfway point, or midpoint. So this is 8. Hey, wait a minute, this is a right triangle, where I know the hypotenuse and I know a side. So we just use our a squared plus b squared equals c squared. And that's what I had on the other side, just really small. And it comes out to 6. So our actual radius of our cylinder is 6. So it's pi r squared, which is pi 6 squared, times our height, which is 16, which comes out to 576. Sphere minus cylinder would be this number, minus this number, had to turn into a fraction. And it comes out to 2,272/3 pi. So the biggest thing you had to know was use the radius from the center of our sphere to actually get the radius of our cylinder. Okay? Questions on that? Do all those steps make sense? It's probably just the radius of the cylinder that's tripped you up, yeah. That was the whole point of that one. Alright, other questions? None? Okay. Well, then we'll move on to the lesson. Mary.
12. I mean, not 12, sorry, 11.
11. Is that right before it?
Yeah.
Number 11 is a sphere has a 60-degree wedge cut out. So we have a 60-degree wedge cut out. So this one isn't super bad or a lot of work as long as you realize what they're asking you. So they said there's a 60-degree wedge cut out. They said the volume of the 300-degree section is 240 pi, ladies. Is 240 pi centimeters cubed. What is the radius of the sphere? So we're given volume. We're given volume, which is 240 pi. Now I'm going to pretend like I don't know this for a second. Well, I know it's 4 over 3 pi r cubed. I know that's the formula. But the thing is, I don't know the entire sphere's volume. I know this 300 degree section. So I know a percent of the sphere. So I'm going to throw that percent right in front, which is just 300 divided by 360. Alright, so no more volume of a sphere, but I don't know the whole thing, so we're going to do our 300 divided by 360. Alright, other questions? All three of you have the same question? Oh, read. 13. Did I already have that one up there? Is 13 two intersecting spheres? No, it's not that one, is it?
Challenge number 1, the whole glass.
Oh, yeah, I have those as challenge. If you want to see those, you can come see me on those. That's why I put them as challenge, so we're not, because they'll take me about 5-10 minutes to explain, and then I'll lose the people that don't care about the challenge. But you can come see me, we can go through it, okay? Other questions that aren't challenge? Do you have a question, Gracie, or are you just going to hear? Oh, okay. No, and that was, remember those surveys you took? Some people commented on, like, sometimes we have really challenging questions and we're not sure if they're going to be on the test or not, so we spend a bunch of time on them and they don't turn out to be the test. So I took that into consideration. I put challenge questions on, all right, that you know aren't going to necessarily be on the test, but if you're in the role of doing stuff, then you can try them and see if you can successfully do the challenge questions, okay? At least then you can be like, oh, I'm at home. It took me like 50 minutes to do this homework. Why am I going to spend another half an hour on challenge questions kind of thing? Bree, did you have a question?
No.
No. Just a comment? No. Okay. All right. So anytime you see challenge, I'm not going to check it for your homework. All right. So if I walk around and check your homeworks right now, I'm not going to see that you did the challenges. It'd be nice if you tried them, but I'm not going to check that you did them. It's for your own benefit. If you can do them, then you know you really know this stuff in depth. Okay? But if you don't have time to do them, then don't do them. Okay? Does that seem fair? Yeah.
So you're like putting off the problems that won't be on a test as challenge,
Yeah.
and then like everything else it could be on.
Yeah, and it won't be every single time. So like the sorted problems are all pretty hard questions, but I could pull parts out of. But the challenge questions that aren't here, I'm not going to pull any parts out of there. But they're interesting problems. If you looked at them, they're interesting problems. Okay, other questions on the homework? Okay. And that's why we fill out surveys, right? So I can retool stuff and make it better for, unfortunately it's late in the year, but next year students will have the benefit of, I'll tell them whether it's a challenge beforehand, so that they know how much they should ask or how much time they should put forth on it. Okay, so today we're going to talk about, bless you. Today we're going to talk about area of a sphere. If I say area or surface area, I mean the exact same thing. So even though this just says area, we could think of that as being surface area as well. Bless you. All right, so volume of a sphere was 4/3 pi r cubed. Surface area of a cube is 4 pi r squared, so we drop 1 power of r, which makes sense. All right, so we're at 4 pi r squared. This is something that has to just be memorized, right? Just like with the volume of a sphere. So surface area of this sphere, my radius is 3.5, so my surface area is going to equal 4 pi 3.5 squared. I believe this comes out to 49 pi. And was I using inches? So inches squared or cubed? But it's 3 dimensions. Oh, it's area. Yeah. So it's like the paint I'd buy to cover it, right? And volume would be water I could pour into it. So surface area is how much paint would cover this. And volume is how much, if I had a bucket of water, how much water could I fit inside of it. That's the big difference between the two. All right, our next one. Well, I have a line there, so my radius must be 4.2, correct? Nope. What is it then? 2.1. Yep. So we just plug in that formula, the surface area formula. And surface area equals 4 times pi times my radius. Well, my radius here is 2.1. And we're going to go ahead and square that guy. And this one's going to be 17.6 pi feet squared. So if you look at the assignment we did before, we did this exact same shapes with the exact same numbers. So it's just showing you can look at both of them to see the difference between volume and surface area. Our next one's a little different, and I don't... oh, you already started it. I'm going to make a change to this. This question doesn't make any sense. We need to change the fact that the radius is 4. We need to get rid of that. And I'll tell you why we need to get rid of that. With radius being 4, it's an impossible... not impossible, but we're not going to be able to solve it. And why it can't be 4? The height of this sphere is 6. So what must the radius be? It must also be 6. Because if from the center to the top is 6, it must be 6 all along. If for some reason this was 6 and this was 4, it wouldn't be a sphere, it'd be an oblong shape. It'd be longer than it was this direction. So we have to get rid of that, and that's going to tell me since my height is 6, my radius is also 6. It's the only way to actually solve this problem. Now we're just doing surface area. I'm trying to figure out how much paint I'd have to buy to paint this object. So we're just going to separate it into parts. The first one we're going to do is our hemisphere. Well, our hemisphere, our surface area of our hemisphere is just going to be 4. So it's a hemisphere, so we have to, I'm going to do the 1/2 out front, times 4 pi r squared, which would be 6 squared. So I need to take half for the fact that it's a hemisphere. You could divide by 2 afterwards also, or you can just recognize if it's a hemisphere, it's just 2 pi r squared. But we're going to come up with 6 squared is 36 times 2, so this is 72 pi, let's just call it centimeters squared. Alright, that is the surface area of that hemisphere. Do you think I need to calculate that circle that's on the base of it? Is that on the surface? No. No, we're not going to calculate anything inside. So as soon as I put this top on, we're not calculating anything inside. So although if this was a hemisphere, I would have to calculate the bottom circle. Since it's put on top of that, I don't have to calculate that bottom of the circle. Which also means this cylinder, a cylinder usually has 2 circles and a rectangle, right? Right? I've seen blank stares. Surface area of a cylinder has 2 circles and a rectangle. This one's just... So we don't need the 2 circles because they're inside, so we're just going to have the rectangle that's formed. Well, the rectangle that's formed is 15 by... How do I get the other side of it? Where? circumference. And our radius is 6, so that's 2 pi 6. 6 is 12, 15. Is that 180? 180 pi centimeters squared. Okay, so that's that guy. Now we have this we haven't done cone surface area in a while. And cone surface area is a formula we just have to have memorized. We did it yesterday too? Oh, I don't remember that. Yeah, what is it?
1/3 pi r squared times height.
No, that is the volume. I'm talking about surface area. Peter,
1/3 2 pi radius times the height.
we're still talking about volume. I'm talking about circumference. Emily. It's pi RL. Surface area of a cone. And if you didn't remember that, go ahead and look it up again. Surface area of a cone equals pi RL. Remember it's like TRL, but with pi. Like pi RL. Pi RL. It's an old show on MTV. It was Total Request Live. It was when MTV played music. You'd call or you'd go on or whatever and you'd request songs and the top 10 requested to be played. Okay, so it's pi RL, where L is this length here. Shh, guys. Is the length from here to here. We don't know that right now. All we know is this height is 12 and our radius is 6. But I do have a right triangle with bases 12 and 6. So let's go ahead and calculate L. Not 6 times 12. Pythagorean theorem for a triangle. So we should be using the Pythagorean theorem. Try to simplify it if you can, too. Did anyone get it? Did anyone get it and want to share it, I guess? Peter, you got it?
36. It's just 6 square root of 3.
6 square root of 3? I think it's square root of 5.
Okay.
I think you just made a division error or something, because you had the 6 correct. All right, so our L is 6 square root of 5. So that's going to go in there, and our radius is going to go in there. This is going to be pi times our radius, which is 6, times 6 square root of 5. Peter, did you see your mistake at all? Or are you just trusting it right now? Oh, okay. Which is going to equal 36 square root of 5 pi. Once again, because that circle is encompassed in here, I don't have to calculate the circle. So I calculate all my surface areas. So it's just adding up the 3 things that I've circled. So that's going to be 252 plus 36 square root of 5 centimeters squared. And that is my final answer. Yeah, did I add something? Did I do? Oh, I missed the pi. I used the parentheses correctly. I missed the pi though. Pi centimeters squared. Honestly, most of the time, if you wrote your pi's all the way here and you missed it down here, I'd just put a little error and I wouldn't take points off. Because it happens, right? You just drop a pi every once in a while. What's a pi between friends? All right, any questions about what we covered today? Hey, just be careful with surface areas that you're not calculating stuff that isn't on the surface. So if I calculate those circles that were in here, I'd be buying extra paint that I don't need. So I'm not taking off the top, painting it, and putting it back on. All right, so just the stuff that's basically exposed to the air. Okay, let's go ahead and start our homework. I'll put the answer guide up over there.